create these, so probably you, okay? So, but here's the thing. With volume of any prism type shape, and by prism I mean there's this, whatever shape is on the bottom, and I'm just going to draw a pentagon one. It's like a uniform width the whole length. And then you've got the same shape at the bottom. So the volume of that is just your area of your base times however many of those are like kind of stacked up. Yes? For a cylinder, well, you guys don't know about CDs, or maybe you do, but you never owned them, did you? CDs, did you? Oh, you did? Okay. Okay, I'm not that old. So with a cylinder, I always think of like, obviously like a big stack of CDs. Like there's the area of one CD. The volume's going to come when you stack all these CDs on top of each other. Yes? So you count all the areas from here and up. So it's, again, it's the area of the base times the height. Area of the base times the height is going to give you the volume of any kind of uniform width. When you jump to a cone, and the same would be true for a pyramid when and if we get there, it's the same. It's the area of the base times the height, but it's just 1/3 of it because of the way it kind of comes in. Does that make sense? Okay? So just think area of base times height. Just with a cylinder, it's a circle, so you get pi r squared. And the area of the base, pi r squared, is the circle of a cone as well. So I think they should be memorized because conceptually they make sense, right? It's not really above you to wrap your head around why those formulas are what they are. So, okay, here we go. The related rate part. At a sand and gravel plant, sand is falling off a conveyor belt onto a conical pile. That just means cone. So here is the pile of sand. Here's your conveyor belt. I don't know how detailed. And the sand is dropping onto it. And it's happening at a rate of 10 cubic feet per minute. So you got to know what rate that is. D what dt? Volume. Yes. Okay. So some of you get that naturally. If you don't, look at the unit. If it's in cubic something, it's volume. If it's in square something, it's the area of something. If it's just, in feet per minute, then it's probably a one-dimensional measurement. So this is dV dt equals 10. The diameter of the base, so that's that, of the cone is approximately 3 times the altitude. So whatever this altitude is, we're going to say A. The diameter is always going to be 3 times that, 3A. That ratio is going to remain consistent. And then at what rate is the height of the pile changing? That will be our A. So we're looking for dA dt. Changing, that's a typo. When the pile is 15 feet high. So specifically when the pile is 15 feet high. So if we kind of look at what we know and what we are being asked for, you should know which formula it is that you're going to derive. Yes? So volume equals 1/3 pi. What's our R? Yeah, which is what? Lily, what were you going to say? 1.5A. So I'm going to do 3/2 A for that. 1/3 pi r squared, and our h is A. Before deriving, I'm absolutely going to clean this up. Don't forget to square your 3/2. 1/3 pi, that's going to be 9/4 A cubed, yes? Again, before deriving, clean it up. Your 3 and your 9 can reduce. So the volume equals 3/4 pi A cubed. Do we have any constants? No, right? Everything is changing. So you can't plug anything in prior to deriving. So we're just going to jump into the derivative. which dv dt, fairly straightforward, just a power rule on the right. So you're going to bring your 9, or your 3 out in front. 3 times 3 is 9/4. Pi a squared dA dt. And then plug in what you know. 10 equals 9/4 pi 15 squared dA dt. Now again, the simplifying part is the underlying beast here. And if you get wrapped up and you start squaring 15, you're going to make your life harder. You almost want to keep these things as small as you can so you can see different smaller factors that would cancel. This is the same thing as, like, well, I don't know how you want to do it. There's so many different ways. But I could divide by the 15 squared right away, which would help over here. Yes? If I divide that 15 squared away, I might want to think of that as 15 times 15. So that a 5 can reduce out of here, making that 2, and a 5 can reduce out of one of those 15s, making it a 3. Then I have to get rid of the 9/4, so I would multiply by the reciprocal times 4/9. So right now that is all that my numbers are going to do. The 4 and 2 up top won't reduce with anything on the bottom. So that'll be 8. 27 times 15 is fairly annoying. And then you would just divide by pi, so that's just going to throw the pi in the denominator over here. So as far as not having a calculator, that's pretty much as far as you could go. Worst case scenario, the answer has 27 times 15 done out. But any questions? What are our units? What's our unit on this? Feet per second, right? Minutes, sorry. And A is a one-dimensional thing, so it's not feet squared, it's not feet cubed. Okay? Another cone, a conical tank with vertex down. The tank itself is 10 feet across the top. So what, most importantly, is the case? Right, radius is 5. I'm not a big fan of ever labeling the diameter because almost always the radius is what you really need. So I just simplify it and get that out of the way right away. And 12 feet deep. So that's the size of the tank. If the water is flowing into the tank at a rate of 10 cubic feet per minute, that's dV dt, that's volume again. Find the rate of change of the depth of the water when the water is specifically 8 feet deep. So think about an empty tank, and this I think we can all wrap our head around. When you first start pouring, is the depth increasing slower or faster than it will later on when the cup is already halfway full? Faster in the beginning, right? Because there's less space. I think we can all, that's a good one to wrap your head around how the rate is changing. So specifically when the water is 8 feet deep. So right at this moment when our depth, what do we want to call that? A? Can we call that A? Is it, because there is kind of a right triangle going on. I don't know if we're going to use the right triangle, but I'm just going to call that A. So A is 8. So here's the piece from here that you just have to kind of know and take from geometry. What is this at this moment, if we call this B? Yeah, but at that moment, the radius is 5 here. The radius isn't 5 down here. What do you know about these triangles? They're similar. So 5 is to 12 as what is to 8. You set up a little proportion there. So you get 40 equals 12x. Divide by 12. Well, it shouldn't be x. I'm going to make it b. So b equals, both of these are divisible by 4, so 10 thirds. So at this moment, b is 10 thirds. They're looking for dA dt. Good. So, volume, 1/3 pi R is B. H is A. So let's just pause here for a second because we have got more variables than we had the last time. If we derive, we're going to have dV dt, which we know, so that's fine. We're going to have dB dt, which we don't know, and dA dt, which we don't know. So you'd have two unknowns. So there's a couple ways to think about this, and I think my favorite way is to find a way to keep the A in there, because that's what we're looking for, but to substitute out the B, okay? And that's going to come from this same concept of this ratio. So 5 is to 12 as B is to A. That ratio is always going to hold true. Yes, no matter where we are, because we're always going to have similar triangles as this fills up. So given that, I can solve for B so as to take it out of there and make this all in terms of just A. So if I cross multiply 5A equals 12B, I want to get rid of this B. So I'm going to solve for B, and I'm going to replace it with 5A over 12. And now I'll only have one unknown when I go to derive. But I'm not going to derive yet because I got some cleaning up to do. So, oh, yuck. I don't know that too much. The top is going to be 25. Nothing is going to cancel with 3 or 12. 5 squared is 25. So this bottom, it will be 3 times 12 squared, so 3 times 144. I'm not going to actually multiply that out. Honestly and truly, I probably should have just keep it 12 squared. 3 times 12 squared, again, because the smaller these numbers you keep them, the easier this crossing things out is going to be. Pi A cubed. You follow? Okay. So derive dV dt equals, we now only have a simple power rule as well. So we also avoid the product rule by doing all that. So if we bring our 3 out in front, what obviously is going to happen? That 3 will cancel. So it'll just be 25 over 12 squared pi A squared dA dt. Plug in what we know. 10 equals 25 over 12 squared pi. A is 8 dA dt. So again here, there's definitely some simplifying that can happen with your 8s and 12s. I would make this probably mentally, and I'm showing more than I would just so people can pick up on it. I'm making that 8 times 8 and this 12 times 12. So 8 and 12 reduces to what? 2 and 3. So 2 and 3, 2 and 3. Then I can divide over one of these 2's. Do you follow? If I divide just one of these 2's over, it'll make this 5. So it's 25 times 2 over 3 squared pi. And then I can multiply by the reciprocal. So times 3 squared over 25 times 2. And then your 5 and your 25 will reduce, and we just have 9 over 10. Yes? I also have to bring this pi over. So divide the pi over, and it'll just be 9 over, oops, that's a D, 9 over 10 pi. The 25 and the 5 reduced down, so that crossed out and that 25 became a 5. It was 5 over 25. Yep. Any questions? All right, a cylinder of constant volume. That's important. What does that tell us about dV dt? 0. I like a picture. I'm doing that. So the volume is constant. This cylinder is being flattened. So think about that visual. If you flatten it, yet the volume has to be constant, what must be happening? It's getting wider, yes? Okay, good. So at the moment its radius is 4. So r is 4, but dr dt is definitely changing. The height is 5. 5 equals h. That's also changing because you're flattening it. And the height is decreasing at a rate of 0.3. So dh dt is negative 0.3. At that moment, what is the rate of change of the radius? So they're looking for dr dt. So take your cylinder volume formula, V equals pi r squared h. If I derive this right now without doing any substitutions, I'll have a dV dt, which is fine, I have 0. I'll have a dr dt, which is fine because that's what they're asking me for, and I'll have a dh dt, which is fine because they told me that. So we don't need to worry about any substitutions here because once we derive, we'll only have the one unknown. So the only thing with this deriving is that you're going to have a product rule, which is fine. First times derivative of the second plus second, h times derivative of the first is 2 pi r dr dt. I just kind of shuffled up that order to make it look better. But there's my second h times the derivative of 2 pi r, or the derivative of the first dr dt. So go ahead and plug in what you know. So we have 0 equals pi 4 squared. Negative, I don't like decimals mixed. I would make that a 3/10. That's just my advice. You can do what you want. I would... This 4 squared I'm going to write as 4 times 4 so that I can reduce this 4 and 10 just a bit. So that would be 2 and 5. So this is 8 times negative 3 is negative 24/5 pi. So I have to add that 24/5 pi over. And then this all is going to be 840 pi dr dt. So if I divide by 40 pi, I just have to keep the 24 pi over 5, change, flip. My pi's will cancel. My 24 and 40 will reduce by a factor of 4, 8, 3, and 5. And I have 3/25 centimeters per second. And it's a positive number, as it should be, because as Winter said, as you shrink it and the rate of the height is a negative, the radius has to fatten, essentially, in order for the volume to stay constant. Good? All right. Oh, God, last one. Water stored in a right circular cone. A right cone just means it's not slanted. Do you know that? Just means that your height is perpendicular to your base. So the water is leaking out at a rate of 2 cubic feet per day. So dV dt is -2 because we're losing it. Assuming the tank is 100 feet high and the radius of its base is 25, again, we're going to have that common ratio. So if I call this A and this B, A over B, no matter where we are, has to be in the ratio of 100 to 25 because of those similar triangles. At what rate is the depth of the water inside the tank decreasing? So they're looking for dA dt. I probably should have drawn this upside down. At the moment, the water is actually 40 feet deep. So when it's actually 40, so what is this at that moment? Just out of curiosity. 100 is to 25 as 40 is to 10. It's a fourth of it. Good. So our volume, 1/3 pi, R is B, squared, H is A. And this is trouble if I derive, because dV dt I know, dB dt I don't know, and dA dt I don't know, because that's what they're asking me for. So I want to keep the A in there because that's what they're asking me for. I want to lose the B, so I don't have to worry about dB dt. Do you follow that logic? Okay? So if I want to lose the B, I want to use this proportion here to solve for B. So B equals 25A over 100. B equals A over 4. So when I plug that in, I can make it A squared over 4 squared if I want to square it as well, times A. So volume will equal 1 over, does 3 times 16 scare you? No. A cubed. Derive, plug in, simple power rule. dV dt equals, I bring my 3 out in front, and immediately the 3 over 48 will reduce, yes, to 1 over 16. Pi A squared dA dt. Plug in what you know. A. At the moment, A is 40. So to get rid of 1/16, I'm going to multiply 16 over, so that'll be -32. Excuse me for just slipping that in there. And then you're just going to divide your 40 squared over, reduce, and divide your pi over, and you'll be done. Okay?